Hello, everyone. I'm Dr. Wen. Here is the question. This question is from linear algebra field. What is the probability of this linear system has a unique solution? Here, the constants A, B, C, D, E, F take one or two randomly. This is a random linear system. I'm going to discuss this problem in two different ways. First method, that's a theoretical method. Second, that's Monte Carlo method using all programming. This linear system, that's a random linear system. For those parameters, each parameter has two options, one or two. How many in this kind of random linear system? Because each parameter has two options. Totally, we have 6 parameters. So here, the total number should be 2 to the power 6. Our question is, what is the probability this random system has a unique solution? In linear algebra, this is 2-dimensional linear system. In 2-dimensional linear system, if the linear system has a unique solution, that means A times D does not equal to B times C. This is the same meaning as the determinant of this matrix is not 0, or this matrix is invertible. So here, based on this condition, A times D does not equal to B times C. Totally, we have 2 to the power situations. So we need to count what is the total number. A times D does not equal to B times C. We consider A times D first. A times D, how many possible combinations? Because all parameters only take 1 or 2 randomly. So here, A equals 1, D equals 1, one situation. A equals 1, D equals 2, second situation. A equals 2, D equals 1, the third situation. The last situation, that's A equals 2, D equals 2. For 2 parameters, we only have 4 different combinations. So we consider left-hand side one by one of the 4 situations. First situation, A times D equals 1 times 1. We want to find the B times C not to 1 times 1, not to 1. So here, the product, only this to 1. This is 2, this is 2, this is 4. So here, B times C has 3 different situations. B times C, 1 times 2, 2 times 1, 2 times 2. All situations are not equal to 1. Similarly, we discuss A times D equals 1 times 2, 1 times 2, second situation. 1 times 2, the product equals 2. So here is another 2. When we pick B times C, we should not pick the middle 2s, only the first one and the last one. So first one and the last one. BC equals 1 times 1 or 2 times 2. For those 2 situations, A times D does not equal to B times C. Here we have 2 possible ways. Consider the third situation. AD equals 2 times 1. 2 times 1, 1 times 2, that's symmetric. So here we have same situation here, two ways. Last situation, A times D equals 2 times 2. 2 times 2, that's the last situation. You have first three situations here. 1 times 1, 1 times 2, 2 times 2. Because 2 times 2, that's 4. Now those product equal to 4. So we have three ways here. So here, how many totally here? That's 3, 2, 2, 3. 10 ways. So the probability equals 3 plus 2 plus 2 plus 3 divided by the total number of possible linear systems, the power 6. In the power 6, we already counted E, F, 6 parameters. But in our counting, we did not count E and F. So here we have to add the factor 2 times 2. So that's 2 to the power 2. We have a combination here. That's 4 different possibilities. Simplify this part because that's 10. 10 equals 5 times 2. 2 times 2, that's square, that's 2 to the power 3. 2 to the power 3, 2 to the power 6. You cancel 3 here. You have 2 to the power 3 here, and 5 in the numerator. 5 in the numerator, that's 8, which is 0.625. That's the theoretical result. Let's consider the second method, Monte Carlo simulation using R programming. By the way, R programming is very popular, powerful in data science, statistics, machine learning, big data. The following R coding, it's very easy to understand if you have little background in programming, like Java, Python, C++, any of those basic languages. So here, why simulation is very powerful? Because when you do something trying to find theoretical result or find the result in a short time period, if you cannot solve it, even use computer, may take more time. So simulation is the very powerful method to solve problem. You will see in this example. First line, I use set seed because Monte Carlo simulation, you always use random numbers. The purpose for setting seed is the following. Everyone, for example, my student, if I give a question to them, I let them set the same seed, they should get the same result. If you don't set, everyone will get the answer a little bit different, but very close. In comparison, I want everyone get the same answer, so you can do this, set seed. If you want set seed, if you run the program, you should get same result as I have. So here, n is the number of iterations we need to run the simulation. Sum is to collect how many number of times the random linear system has a unique solution. So here, we use a for loop to run the simulation n times, I from 1 to n. So here inside part A, B, C, D. So first thing we need to do, we need to simulate, generate A, B, C, D values. Those 4 parameters only have 2 different kind of value. One is 1, the second one is 2. Now how to generate? So here, default is 1. So what is this? I means indicate. We call random number. Random number is a number in between 0 and 1 continuously, uniformly. So we cut 0.5. If this random number before 0.5 before 0.5, we said this A will return number 2 as its value. Because here's 1 indicator is true. This will return another 1. 1 plus 1 is 2. If the random uniform number is bigger than 5, this indicator function is false. False will return 0. So A will take its value 1. Similarly to B, C, D. So we are generating 4 parameters. They are taking 0, 1 or 2 randomly, equally likely. Now, after we have the value for A, for B, for C, for D, so we need to check if A times B is not equal to D times C. Only this is true, the linear system has a unique solution. If this is true, it will return value by 1. So we are keep counting. Summation means what? We're counting how many number of iterations. Among those iterations, how many of them are ones? That means the linear system has unique solution. So this is a counting clock. Keep counting. When we finish the loop, this loop will return a variable, sum. The value is the total number of system has unique solution. We consider the ratio. Sum divided by n is approximation of the probability the linear system has a unique solution. We print out, we will see the result. If this numerical simulation approximation is close to 508, which is 0.625. Our simulation result, so that's 0.6261 if we use this seed. The theoretical result, that's 0.625, is very close. If you put 2 more zeros here, increase the number of iterations, you will get a more accurate result. Let's see the Monte Carlo simulation run. So here's the code here. Now we can run it. You can see the result. So here, I did not set the seed because I block. You see here, if I use the same seed, we will have same result. Same result, 0.6261. Right? That's the result that we have here. 0.6261. So here, if we don't use the seed, block this one, don't use the seed, use a random seed. Each time you will return a different number here, comparing with this one. So here, we run different, right? 6.629, right? Again, you get a different one, 0.6174, right? Each time you are wrong. Yeah, that's a Monte Carlo simulation. You can see the code is very easy, very short. It's very powerful to get the answer. So this is also the way to check if your theoretical result, if it is correct. If it is incorrect, you will have a big difference. That's all. Thanks for watching and see you next time.